Hello students, this is Ms. Cave with a lesson on similar rectangles and figures. Today we are going to do a sort of rectangles. You should have rectangles in front of you with letters on them, and we're going to talk about what it means for shapes to be similar, and then we're going to actually do a sort. We're going to pair up our rectangles with other rectangles based on what similarity is. So in your notebooks, you are going to be gluing, but not until I tell you to do so, on page 34. So today we're actually working on page 34 in our notebooks. And as we go through the examples and we talk about which ones are similar, we're going to write some notes in our notebook and we're going to glue down our rectangles. Okay? So to begin the lesson today, we had So you cut out your rectangles and you threw away your trash, and now we're going to talk briefly about what it means if two shapes are similar. So I want you to look at the two shapes, the red shape and the purple shape, and I want you to think to yourself, are these two shapes similar? And how do I know if two shapes are similar? So think to yourself, are these two shapes similar? And how do I know? So we need to be thinking about what our definition is of similar shapes. So now you've had a moment to think about it. Go ahead and talk briefly in your groups about whether those two shapes are similar and how do you know if they're similar. So go ahead and have a quick conversation about it. All right, so let's talk about it. Are they similar or not, and how do you know? Miriam. Okay, so you can see if they have the same sides. So what are you telling me about similarity? They have to have the same sides? Okay, so she's saying for shapes to be similar, they have to be the same size and the same shape. Do you guys agree or disagree with what she said? That they have to be similar, shapes have to have the same size and the same shape. What do you guys think about that? For similarity. Yes or no? Thumbs up if you agree, thumbs down if you disagree. Okay, so a lot of you agree. Does anybody disagree? Now there is a word that goes with same size and same shape, but it's not similar. If a shape is the same size and the same shape, there's another word that we use to describe shapes that are the same size and same shape. Does anybody know what that word is? Kendra? Congruent. Yeah. So you've actually given me the definition of congruent. If two shapes have the same size and they're the same shape, we say that they're congruent. They're exactly the same. But shapes can also be similar and not congruent. So what if they're similar? What must they have? Kirshen? The same what? So the shape has to be the same measurements with the height and the length, or the length and the width. She's close to it. Kendra? Okay, so she's telling me her definition for similar would be that it has the same size or same shape, but it has a different size. You don't have to write it down right now, we're just talking. So this is a good definition. We're going to get a more specific definition today, but same shape, different size would be similar. Okay, so are those two shapes similar? No. Kosia, you say no. Why? Okay, so she sees that they're actually different shapes. So she's telling me the red one is a rectangle and the blue one is a square. So since they're not the same shape, they're not similar. Okay? So what we know about similar shapes so far is that they have the same shape. They must have the same shape, which these two do not, because one's a rectangle and one's a square. But they're going to have, they can have a different size. So what you guys have in front of you are rectangles. And I want us to, we're going to do this together to start. I want you to grab your rectangle that has an A on it. So we're going to start with A. So I want you to grab this one. And then I want you to look at your other rectangles. There is one and only one rectangle that is similar to A. So I want you to try to find the match for rectangle A. So look at all of them and see which ones you think, which one do you think has the same size, or excuse me, the same shape, but is a different size? Because none of them are congruent. You can see none of them are exactly the same. But see if you can locate the rectangle that has the same shape, but maybe a different size. And we're going to pause the video and come back. Okay, I'm going to try. Okay. All right, so we have A, and I saw a variety of shapes that go with A. So what are some of the matches that you guys came up with for A? Adriana? Okay, so she says that B goes with it. Does anybody have a different one that they thought went with it? Tracy? C, she said maybe C goes with there. Let's start with C. We're going to come back to B. So Tracy, tell me why you think that A and C are similar. So she said that half of C, the length, right? So she's saying that C, the length is 6, and A is half of it. So that's how you're proving it? Okay, what about the width of A and C? What's true about their widths? What's true about the width of A? It's equal. So the width of A is 2, and the width of C is also 2. So do you think these two are the same shape? Okay, so she's telling me she sees a relationship between 3 and 6. What's the relationship between 3 and 6? It's times 2, right? What's the relationship between the 2 and the 2? They're equal, or times what? Times 1. Okay, so do you think that means they're similar if one of them there's a relationship and the other one it's the same? What do you guys think? All right, so we've looked at A and C. Now let's look at A and B. So let's look at A and B and see what the relationship is. I'm just going to bring it down here so we can keep that there. So we're going to look at the same thing because one of these is similar. All right, so let's talk. Who told me it was A and B? Adriana, so why do you think it's A and B? Oh, you're saying that it takes 4 of the A's to make a B? Okay. Let's look at the reasoning that that Tracy had. Let's look at the side length. So what is the width of A? 2, right? And what is the width of B? 4. All right. And now let's look at the width of A again, or the length. What is it? 3. And then what's the length of B? 6. All right. So I want you guys to look at that and tell me which one do you think is more similar? A to C or A to B, and how do you know? Talk about it. Look at the relationships between the side lengths. Which one is more, seems to be similar? One is similar and one is not. So talk about it. Talk about it in your groups. What do you guys think? Think it's Adrianus? Okay, so what do you guys think? Which one do you think is similar? A and C or A and B? Ellie, what do you think? You think it's A and C? Why? Okay, so you guys are looking at the area of the shapes. Okay, what we need to be looking at is the relationship between the side lengths. So I'm going to show you something. Maybe not. Thought I put it in here. Okay, let me just draw something. Let's say I draw a heart. And then I'm going to clone it. Okay, those two are what? They're what? Congruent, right? And then if I stretch it here, now what are they? Similar, right? So they're the same shape, but different size. Now I'm going to take this again, and I'm going to clone it. Of course, it's not going to work. It's not going to let me do it. So every time I do this, the length and the width are increasing at the same level, right? So if I click this, I'll click this one and drag it. You see how the length and the width are increasing at the same rate? Okay. I was trying to show you one. Sorry, I'm trying to figure this one out. So let's try drawing, let's see if it'll work with a rectangle. I thought it should. So if I draw this rectangle, and I'm going to give it a color because it's prettier. What color? Blue? Well, it might be nothing if I can't get the thing to work. Okay, so there's blue, and I'm going to clone it. Shh. These are now what? What are they? Congruent. Now what are they? Now what are they? Or what are they now? What are they now? Do you? Okay, so are those two similar? They're not. They're not similar. Why not? Viviana? It doesn't look equal. This one on the left is thicker and the one on the right is skinnier. So I've changed the actual shape. It's still a rectangle, but these are not similar. So what we need to be looking for similar shapes, if we go back to what we had before, the examples, if I can get to it. Okay, here. So what you're looking for is A and B are actually the ones that are similar. Because you're looking that they have the same relationship between their side lengths. So if you look at 2 to 4, that's a times what relationship? Times 2. And then the 3 to 6 is also a times what? Times 2 relationship. So what is that called when you have two ratios that are equivalent? Starts with a P. Proportional. Proportional. So watch this. I'm going to erase this real quick. So what I want you to do is on that page in your notebook, I told you to go to page, I think it was 34. I want you at the top of your page to put A and B next to each other and then do what I'm doing up here. So you're going to take A and B, yes, at the top of your page, and I want you to leave room so that you can write the side lengths. So A's 2, the corresponding side length with A that goes with B is a 4. And then over here, the width or the length of A is 3. And this is 6. So you're going to glue it at the very top so you have room for all your pairs. Okay, so you're listening while you're gluing. Okay, you're listening while you're gluing. You've pasted them on your paper. You've labeled their sides. And then what I want you to do is I want you to write the proportion. So our proportion here is 2 over 3 is equal to 4 over 6. We know that it's equal because it's a times 2 relationship. As we double the side length, the shorter side, we also double the larger side, and that makes them similar. So you can't just look at them to tell. You have to look at their side lengths. Just like somebody said, you have to know the measure of the side lengths. And you have to look at the relationship between the side lengths. So this is actually a times 2 relationship. So what you're doing is you're putting those in your notebook, and then next to the shapes, you're writing down in your notebook the relationship that I have there. This is really important for us to understand what similar shapes are and what the definition would be. So once you've written that down, I want you guys to grab C. I want you to grab C and go ahead and find the match that goes with C. And think about what we just did. The sides have to be what? Not equal.
Congruent.
Not congruent.
Similar.
Not, the sides have to be,
Equal.
what is that? Proportional. The sides have to be proportional. So find the rectangle whose sides are proportional to C. All right, so I'm going to go ahead and erase what I had for A and B so we can start the next example. So now we're going to pull these two away. We've already matched those up. And so I'm going to grab C. I'm going to grab C, and then I'm going to find the one that goes with C. So the side lengths of C are 2 and 6. So you're going to find the rectangle whose side lengths are proportional to 2 and 6. So you're looking for the one that's proportional to 2 and 6. And you can use your calculator to check. Okay, and so once you've done that, I want you to write on your, if you're right next to it, maybe don't glue it yet, but write the side lengths on your paper. Did you guys find the one that goes with C? Okay. All right, which shape did you find to go with C? Lauren? She says H. Which one? Why do you think that they go together, Lauren? Okay, so she found that the 1 goes with the 2 and the 3 goes with the 6. So if I write this as a what? Proportion. If I take the side lengths and I write it as a proportion, I can see that they're equivalent because it's I'm dividing by 2. If I divide the short side of C by 2, I get 1. If I divide the short side of, or the long side of C by 2, I get 3. So we can see that they're proportional. They have the same relationship. Does anybody see a relationship going vertically? We see the horizontal relationship, right? Going across, the horizontal relationship is that divided by 2. But do you guys see the vertical relationship, which would be this? Farah? Yeah, there's also a times 3 relationship between the side lengths. The long side of, if you can see here, the long side of C is 3 times the short side. The long side of H is 3 times the short side because 1 times 3 is 3. So you can look at it that way, just like we did when we were doing proportions and word problems. You can look at the relationships going vertically, and you can also look at them horizontally. So what I want you to do is to go ahead and write underneath, because you're going to need room for 6 pairs. Glue these and then write down your proportion to prove that they're similar. Because the side lengths have to be what? Proportional. That's okay, because you switched it. All right, once you've glued down C, we're going to go ahead and grab D and try to figure out which rectangle would go with D. So you're going to do D next. Figure out which one goes with D. So be looking for the match that goes with D. Did you guys find it? What is it? Okay. Okay, so we're going to find the one that goes with D now. So we've used C and H. So now we have D. Which shape did you find is similar to D? Maya? G. She says G. Okay, why do you think it's G? If I multiply what by 2? If I multiply 1 by 2, I get 2. So that's going to be a times 2 relationship, right? But what about the other side of D? If I take 2, and then what's the other side of G? 2. So what would I multiply 2 by to get 2? Times what? That'd be a times 1. So are the side lengths proportional? Is D proportional to G, Maya? No, because the relationship, it's a times 2 and then it's a times 1. So it's not G. Which one do you think it should be? E. Let's take a look. So I'm going to grab this one. Okay, so who can tell me why D and E are proportional or similar? How do I know they're similar? Sanai, how do you know D and E go together? So she's saying if I take the long side of E and I divide it by 2, I get 2. And then what about the other side length? So she's saying this is a division by 2, that D's long side is half the side length of E. And then what about the other 2? And then if I take the 2 for the bigger shape and I divide that by 2, I get 1. So then my proportion here would be 1/2 is equal to 2/4. And she was thinking about it as dividing by 2 because she was going from the larger one to the smaller. But if I looked at it this way, it's a times 2 relationship. But either one is fine. Okay? Make sense? So go ahead and glue these down in your notebook and write down your relationship. And then let's go ahead with F. F. So you're going to do F next. So you're looking for the shape that is similar to F. You're going with F. F. All right, so now that we've copied this down, we're going to go on. I'm going to go ahead and erase this so that we have the room on the smartboard. We've already matched up D and E. We found them to be similar. And now we're moving on to F. So who has the match for F? Kendra. So Kendra says F and J go together. So if you notice when I pulled up J, it's facing a different direction. So I have like the short side with the long side. You could keep it that way. It's just been turned. Or you can just turn it so that you can look at it better. Because you actually cut out the shapes, you can see it better that way. So who can prove to me why J and F are similar? Michaela. How do you know that F and J are similar? You don't think they are? Well, then tell me why you think they're not. Okay, well, let's take a look. What is the long side of F? What's the long side of F? 5. What's the long side of J? 10. So what's the relationship between 5 and 10? It's a times 2, right? So now let's take a look at the short side. What's the short side of F? 1.5. What's the short side of J? It's 3. So let's see if 1.5 is 1.5 times 2, 3. Is it 3? So are these two similar? Yes. So go ahead and glue down F and J. They're a match. F and J are a match. So what I would like you to do now, there are 2 remaining matches. I want you to find the 2 remaining matches and glue them into your notebooks. Check them with your group before you glue them down. You should be able to figure it out. There's only 2 remaining matches. So you're going to find the 2 remaining matches and you're going to glue them into your notebook. And once you are finished, once you've done that, you can pause the video and then you can check your work with my notebook. And what you should have are the remaining 2 similar shapes. You guys got it? The last two. I'm stuck. There we go. So if you look down here, I have the last two remaining shapes. So in my notebook, I have K matches up with I because the short side of K is 2 and the long side is 8. The short side of I is 1.5 and the long side of I is 6. So I saw from here, if you look here, the relationship that I noticed is the 2 and the 8, the short and the long of K was a times 4. And then the short and the long of I was also a times 4 because 1.5, 1.5 times 4 will give me 6. So that's how I proved that one. Another thing you guys could do is use the cross products. You could multiply diagonally because 6 times 2 is 12 and 8 times 1.5 is also 12. So we have many different ways of looking at that relationship. So let me show you what I mean. So you could also do 8 times 1.5, that's 12. And 6 times 2 is also 12. And we know if the cross products are the same, those two ratios are going to be proportional. And then if you look up here, the other match would be G and M. So if you look at the relationship, again, if you look at the vertical relationship, the relationship between the sides, they're the same, right? So the 2 and the 2 is a times 1 relationship. And the 5 and the 5 is also a times 1 relationship. And these shapes are both what shape? G and M are both what? They're both squares. All squares are going to be similar because they're going to have that 1-to-1 ratio. So make sure that you get each of these pasted in your notebook. And so down here, we're going to kind of close the lesson with similar shapes. One thing they must have is all angles, the corresponding angles, the ones that go together, are congruent. So the angles must be exactly the same because we know with rectangles, they're all 90-degree angles. And then the other thing about similar shapes is corresponding sides, the sides that go with each other, corresponding sides are what? What's that word we used? They have the same relationship, so they're what? Proportional. And we can prove it by writing them as equivalent ratios and looking for the multiplicative relationship between them. So when I mean the angles must be congruent, the corresponding angles. So like this angle here goes with this angle. It doesn't matter so much with rectangles because all of the angles are going to be the same. But when we start looking at different shapes, we have to line up the angles to know that they're the same. And we'll talk about that tomorrow with our examples. We'll be looking at triangles and trapezoids in addition to rectangles and squares. And that's it for our lesson. I'm just stopping the video. You guys can keep writing. That's it for our lesson on similar rectangle sort.